Hi, this is a brief video showing how to use SPSS to carry out a paired t-test. That's where you've got one group being tested twice. So you have two sets of variables for one group. Classic example might be a before and after test for, say, drug testing or some training, or in this case, salaries before and after gaining a degree. So we've got two sets of variables, one for salary before and then graduation or grad sal for afterwards. So as we need to analyze it, we'll click on Analyze, come down to Compare the Means, and you see Paired Sample T-Test. Click on that. Now we've got to choose, I'll just reset that to show you. We've got to choose. So we've got salary before, put that across as our first variable. Grad salary is the salary after graduation for the second salary. Click on Options. It's set at 95%, which is acceptable, so we'll go Continue. Then, as we've got our details in there, we click OK. Now, this is where we get our tables of results. Now, we've got our two sets of means here. We are testing the means against each other to see if there is a significant difference. And we can see straight away that obviously there is some basic numerical difference between the two, before and after, and we can see that after they've graduated, it's higher. So, with that in mind, we'll then use that as a common sense measure for when we go through the results. Now, coming down here, this mean figure is the lower figure subtracted from the upper figure here. So that's this one being subtracted from this one, which gives you a difference of minus 3283.33 recurring. Okay, the standard deviation and the standard error are both to do with this mean. Now the confidence level we set at 95%, so we can be 95% confident that our mean will fall between these upper and lower values. The t-value at negative 9.466 is quite low. We've got DF, or degree of freedom, of 29, which is just n of 30 minus 1. And then on the significance, and we've done two-tailed test here, it's come out of significance as 0.000, but somewhere over to the right here there will be a 1. We never have absolute 0 on these, so normally we'd write this as p equals 0.001 to show it's a very low value, but there is some figure out there beyond the range showed in the test. So when you write this, do it p equals 0.001. Now what this is showing is that we will reject the null hypothesis because we set a test saying that p was going to be equal to or less than 0.05. Remember, our confidence level was 95%, which equates to 0.05 for the p. So as it's less, we would reject the null hypothesis that there is no difference after training, and we can quite clearly see that there was a difference, an increase in the size of the mean average salary after graduation.